Hello students, welcome to Nilachal Polytechnic. Myself Amarendra Mishra. Here in this video I am going to explain about the derivation of Bernoulli's theorem. Before derive the equation of Bernoulli's theorem, we are going to discuss about what are the assumptions are to be done in Bernoulli's equation. The first assumption is that the fluid is ideal one. Ideal fluid means the viscosity of the fluid is 0. Next one, the fluid is incompressible. At any cross section or at any section of pipe, the density of the fluid remains constant. The flow is continuous, steady and laminar. The flow of liquid is always happening from inlet to the outlet. There is no interruption in the flow of liquid. The flow is steady means pressure, velocity, density of liquid remains constant at from inlet to the outlet. The flow is laminar. All the flow layers are straight enough, are parallel to each other. They are not crossing with each other. There is no external force except the force of gravity or pressure acts on the fluid. Let's come to the derivation part. Let us consider a pipe as shown in the figure. We are having a datum line, means that is the ground surface. A pipe is in the position of inclined one, where there are two heights. The center of pipe is at a distance of Z1 and Z2. This Z1 is known as your datum head at inlet. Z2 means datum head at outlet. P1A1, the pressure of liquid at inlet 1 and area of cross section at inlet is A1. Similarly, pressure and area at outlet is P2 and A2 respectively. Let us consider there are two parts. One is your inlet 1-1 and outlet 2-2. The pipe 1 is a trapper section. The diameter of pipe is gradually decreases from inlet to the outlet. Let us consider there are another two sections 3-3 and 4-4. Let us consider the flow of liquid is carried out from inlet 1 to inlet section 3-3 with a distance or length of travel is del L1. Similarly, from continued equation, what much amount of liquid is flowing at the inlet, that amount of liquid should be discharged at the outlet. So, the amount of liquid flowing from section 2 to 4-4, that is with a length of travel del L2. Let us consider V1, V2, the velocity of fluid at inlet and outlet respectively. We have to find a relationship that what is the pressure energy at inlet and outlet, what is the kinetic energy at inlet and outlet, what is the datum energy at inlet and outlet. As shown by the figure, the datum head at inlet is more and the datum head at outlet is less. The pressure energy at inlet is more because of area is more, and the pressure energy at outlet is less because the pressure is less, the velocity is more. Here there is a loss of pressure energy of liquid takes place. We know that energy cannot be created, cannot be destroyed. It is only transferred from one pressure and one energy level to another energy. due to the area difference for the two cross section of the pipe, we are going to see that the pressure energy going to be reduced. That is the loss of pressure energy taking place. But there is a gain in kinetic energy takes place. The gain in kinetic energy means the area at the inlet is less, so velocity is less. The area at outlet is less, so velocity is more. The velocity increases means kinetic energy increases from inlet to the outlet. So the loss of pressure energy is in terms of gain in kinetic energy, and there is also gain in datum energy. Let us consider the pressure energy at inlet. The pressure as energy at inlet means P1 into V1. P1 into V1 means we have taken 1 section to 3 section. Del L1 is the length, area is A1. So the pressure energy at inlet is equal to P1 into V1 volume V1. So P1 A1 into del L1. Similarly at outlet, same discharge will be obtained, P2 into V2, where P2 A2 and del L2. Let us consider from continued equation, mass of liquid flowing at inlet is equal to mass of liquid flowing at outlet. So we are assuming that A1 del L1 is equal to A2 del L2, because for a incompressible fluid, the volume of liquid at inlet is equal to volume of liquid at outlet. So A1 del L1 is equal to A2 del L2. Let's see, the loss of pressure energy is equal to PE, that is P1 V1 minus P2 V2. If you are considering the head of water or the pressure head, then we are going to make that pressure energy per unit weight of the liquid. So that is W. We know that W is equal to specific weight into volume. Specific weight is equal to rho g and volume is equal to A1 del L1. Now taking common A1 del L1 bracket P1 minus P2 divided by W, putting the value of W as rho g A1 del A1 del L1 cancel out. Now that is equal to P1 minus P2 by rho g. So this is the loss of pressure head between the two cross section, that is P1 minus P2 by rho g. As we know that the kinetic energy is increased because of the area of pipe is more at outlet and less at inlet. Hence we are going to find out that because of difference of area, the velocity at inlet is less, the velocity at outlet is more. The kinetic energy at inlet is equal to half mv square. The kinetic energy at outlet is equal to half mv2 square. So the pressure energy drop is in terms of gain in kinetic energy. So the gain in kinetic energy means kinetic energy at outlet minus kinetic energy at inlet. If you are considering kinetic head, so kinetic energy 1 to 2 divided by weight. So weight is equal to rho g. We know that mass into acceleration is weight. So mass will be neglected from there is a common of mass 1 by 2 v2 square minus v1 square. So mm cancel out and the rest of term is reduced to 1 by 2g v2 square minus v1 square. This is the gain in kinetic head. Similarly, there is a gain in datum energy also taking place. So due to the difference of height or the center of pipe is at a distance from ground level and it is at different height, so we are going to see that the change in datum head is also mg z2 minus z1, and the datum head is equal to datum energy by weight. So mg z2 minus z1 divided by weight, and that is you are going to find out W is equal to mg. So mg cancel out. So change in datum head is equal to z2 minus z1. We have to establish the relationship between that. The energy cannot be cannot be created or neither be destroyed. So we are getting loss of pressure energy in terms of gain in kinetic energy plus datum energy. So total pressure head is equal to kinetic head plus datum head. So P1 minus P2 by rho g equal to V2 square minus V1 square 2g plus Z2 minus Z1. That implies P1 by rho g plus V1 square by 2g equal plus Z1 is equal to P2 by rho g V2 square 2g plus Z2. So this is the total head at inlet is equal to sum of pressure head, kinetic head, datum head. This is the sum of pressure head, kinetic head and datum head at outlet. So according to Bernoulli's theorem, total energy, total head at inlet is equal to total head at outlet. Thank you.